So in this video, we'll see how a transformer works. Okay. So see, you have a primary coil, and let's say you give an alternating current to the primary coil. Okay. Now since the current is changing at every instant of time, the magnetic flux linking with the coil will also change, correct? Now what we have is, so we have a primary coil, secondary coil, and we have a core, correct? Now here we usually use soft iron because soft iron has very high permeability, which will increase the flux density, okay, which will increase the flux basically. So as the flux in the primary is increasing, it comes in contact with the secondary, right? So we have phi p to be the magnetic flux due to the primary, and then phi s is the magnetic flux due to the secondary. Okay. Now see, the flux is completely dependent on the number of turns, correct? Because more the number of turns we have, more will be the magnetic flux. So we have phi is proportional to n, right? Now we have phi p proportional to np and phi s proportional to ns. So if you take the ratio, you will get phi s by phi p is equal to ns by np, right? Or you can take the other way around also, which is phi p by phi s is equal to np by ns. Okay. Now you cross multiply, you will get phi p is equal to np by ns into phi s, right? Okay. Now if you guys remember, in the previous chapter in induction, we did E is equal to minus d phi by dt, right? So what we have is, we have this equation phi p is equal to np by ns into phi s. Now we differentiate that. D phi p by dt is equal to d by dt of np by ns into phi s. Okay. So d phi p by dt, so we'll call it as a minus ep, that is the EMF in the primary. So we have minus ep is equal to np by ns into minus es. Negative sign cancels, correct? So we get ep by es is equal to np by ns. Okay. So this is what we have. Alright. So that means the EMF induced depends on how many turns we have in the primary or the secondary. Okay. So here what we have is the number of turn ratio, correct? So the number of turn ratio, this np by ns, this is called as transformer ratio. Okay. We represented this by k. Now see, we have the EMF, you can say relation. We also try to derive the current and the number of turns, okay, or current and the EMF. So both of them we try to calculate. Alright. See, we have instantaneous output power is equal to instantaneous input power, right? So we have ES into IS is equal to EP into IP, because VI is the power, right? Okay. So what we have, we get, see, ES, right? So we cross multiply, that is we have ES by EP is equal to IP divided by IS. Okay. Now using this only, what we have is, in the step down transformer, so the current will increase, and in the step up transformer, the current will decrease. Okay. Because ES by EP, we can also take the turn ratio, correct? So using the turn ratio and using this EMF, we can get to know what current we will get in the output, either more current or less current. Okay. So here, whatever we are going to do in the next coming videos, so it will be based on the formula what you have. Okay.